Hey there, and welcome. Today we're going to dive into the super cool world of light. Now, you probably think of it as just traveling in a perfectly straight line, right? But what if I told you it can actually bend, bounce, and play some pretty wild tricks on your eyes? Let's get into it.
Okay, so check this out. It's a simple little experiment. You put a coin in an empty bowl, you see it exactly where it is. No surprise there. But then you add water, and suddenly, the coin looks like it's lifted up. Like the slide says, it's not what you think. And no, it's not magic, it's pure physics. It's one of the fundamental secrets of how light behaves. Right? So what is actually happening here? How can just a little bit of water completely change where an object seems to be? Answering this question is the key to unlocking some of the most amazing illusions you see every day. To crack this little mystery, we first need to look at one of light's greatest talents, its ability to pull off what looks like a bending magic trick. And there's a name for this incredible bending. It's a phenomenon called refraction. It's a huge concept in physics, and trust me, once you get it, you're going to start seeing it absolutely everywhere.
All right, let's pull back the curtain a bit. It's time to get into the science of it all. How, and more importantly, why does light bend?
So, what is it? Put simply, refraction is just the fancy word for light changing direction when it zips from one see-through thing to another. Like from the air into a glass of water, or from the air through a window pane. So why does light bend in the first place? Well, it all comes down to one thing: speed. You see, light is a speed demon in the air, but the moment it hits something denser, like water or glass, it has to slow down. And it's that sudden slam on the brakes at the border that forces it to pivot and change direction. And here are the two golden rules for how it bends. On the left, when light enters a denser material, like going from air into water, it slows down and bends towards the center. But on the right, when it leaves that water and goes back into the less dense air, it speeds up again and bends away from the center. Okay, so now that we've got the basic rules down, let's get to the fun part, seeing how this simple little principle creates some of the most mind-blowing illusions in nature. All right, let's go back to our coin. The light rays bouncing off the coin bend away from the center as they leave the water to reach your eye. Here's the catch. Our brain doesn't know about the bend. It just assumes light always travels in a straight line. So it traces those bent rays backward in a straight line right to position B, making it look like the coin is shallower than it really is. And get this isn't just a trick you can do in a bowl of water. This happens on a massive planetary scale. Earth's atmosphere is way denser near the ground than it is up in space. So even after the sun has technically dipped below the horizon, its light rays get bent downwards by our atmosphere towards our eyes. The result? We see the sun for a few extra minutes after it's already set. This is the exact principle that makes every lens work, from your eyeglasses to the Hubble Space Telescope. And what about the famous desert mirage? Yep, you guessed it, pure refraction. Hot sand heats the air right above it, making it less dense than the cooler air higher up. So light from a distant palm tree traveling down towards the ground gets bent upwards as it hits that hot, thin layer of air. Your brain sees this light coming from the ground and goes, hey, that must be a reflection in some water, creating a perfect life-saving illusion of an oasis. So that's what happens when light goes through stuff. But what about when it hits something it can't go through? For that, we're going to switch from bending to bouncing. And all we need is a spoon. Yep, it doesn't just bend, it bounces. And we call that reflection. Now, flat mirrors are one thing, but things get really, really interesting when the surface doing the reflecting is curved. And believe it or not, the best way to understand this is with something you probably have in your kitchen right now, a shiny spoon. The inside of the spoon, the part that's caved in, is one type of curved mirror. And the back, the part that bulges out, is another. And you've probably noticed your reflection looks totally different on each side. So here are the two types. The inside of the spoon is a concave mirror. It causes light rays to come together or converge. Now flip it over. The back of the spoon, the part that bulges out, is a convex mirror. It does the exact opposite. It spreads the light rays out, making them diverge. Converge and diverge. That is the key difference. All right, so how do these converging and diverging mirrors actually show up in our day-to-day lives? Let's take a look. Okay, before we go any further, we need to get one thing straight: the difference between a real image and a virtual image. A real image is formed where light rays physically cross paths. You can actually project it onto a screen, like at the movies, and real images are always upside down. A virtual image, though, is what you see in your bathroom mirror. The light rays only look like they're coming from behind the mirror.
It's always upright, but you can't project it on a wall.
And this is where concave mirrors get really cool. They're like shapeshifters. If you look at the inside of the spoon from far away, you see yourself upside down and tiny. That's a real image. But as you bring the spoon closer to your face, boof, the image suddenly flips right side up and gets huge. Now it's a virtual image. This amazing ability is super useful.
So where would this be useful? Well, think about your dentist. To get a really clear, magnified, and upright view of your tooth, they hold a tiny concave mirror very close to it. This creates that big virtual image, which makes their job a whole lot easier. Makeup mirrors and shaving mirrors work the exact same way.
Convex mirrors, on the other hand, are specialists. They do one thing really well: give you a super wide view. Your car's side mirror is a perfect example. It's a convex mirror that shrinks everything down to squeeze a huge area into that small space. It's all about safety. The mirror is trading size for a much wider view of the road, which is why they always have that little warning: objects in mirror are closer than they appear.
So there you have it. From a sunset that isn't really there to the weird reflections in your spoon, our world is just filled with these incredible illusions created by light bending and bouncing. But they aren't magic, they're just physics, following a few simple rules. Now that you know them, what illusions are you going to spot today?